What are the various forms of normalization? Normal forms are used to eliminate or reduce redundancy in database tables. The different forms are as follows. First normal form. A relation is in first normal form if every attribute in that relation is a single-valued attribute. If a relation contains a composite or multi-valued attribute, it violates the first normal form. Let's consider the following students table. Each student in the table has a name, his/her address, and the books they issued from the public library. Student table. As we can observe, the books issued field has more than one value per record, and to convert it into one NF, this has to be resolved into separate individual records for each book issued. Check the following table in one NF form. Students table, first normal form. Second normal form. A relation is in second normal form if it satisfies the conditions for the first normal form and does not contain any partial dependency. A relation into NF has no partial dependency, i.e., it has no non-prime attribute that depends on any proper subset of any candidate key of the table. Often, specifying a single column primary key is the solution to the problem. Examples. Example 1. Consider the above example. As we can observe, the students table in the 1NF form has a candidate key in the form of student address that can uniquely identify all records in the table. The field books issued, non-prime attribute, depends partially on the student field. Hence, the table is not into NF. To convert it into the second normal form, we will partition the tables into two while specifying a new primary key attribute to identify the individual records in the students table. The foreign key constraint will be set on the other table to ensure referential integrity. Students table, second normal form. Books table, second normal form. Example to consider the following dependencies in relation to R, W, X, Y, Z. Here, WX is the only candidate key and there is no partial dependency, i.e., any proper subset of WX doesn't determine any non-prime attribute in the relation. Third normal form. A relation is said to be in the third normal form if it satisfies the conditions for the second normal form and there is no transitive dependency between the non-prime attributes, i.e., all non-prime attributes are determined only by the candidate keys of the relation and not by any other non-prime attribute. Example 1. Consider the students table in the above example. As we can observe, the students table in the 2NF form has a single candidate key student_ID, primary key, that can uniquely identify all records in the table. The field salutation, non-prime attribute, however, depends on the student field rather than the candidate key. Hence, the table is not in 3NF. To convert it into the third normal form, we will once again partition the tables into two while specifying a new foreign key constraint to identify the salutations for individual records in the students table. The primary key constraint for the same will be set on the salutations table to identify each record uniquely. Students table, third normal form. Books table, third normal form. Salutations table, third normal form. Consider the following dependencies in relation to R, P, Q, R, S, T. For the above relation to exist in 3NF, all possible candidate keys in the above relation should be P, rupees, QR, T. Boy's code normal form. A relation is in Boy's code normal form if satisfies the conditions for third normal form and for every functional dependency, left-hand side is super key. In other words, a relation in BCNF has non-trivial functional dependencies in form X, Y, such that X is always a super key. For example, in the above example, student_ID serves as the sole unique identifier for the students table and salutation_ID for the salutations table, thus these tables exist in BCNF. The same cannot be said for the books table, and there can be several books with common book names and the same student_ID.